Okay, let's look at these practice problems on page 212 of your textbook. And we'll start with number 41. So for number 41, it says, there's a picture with a mass of 3.8 kilograms. It hangs on a wall 2.1 meters above the floor. So you have a picture. That's your picture. It has a mass of 3.8 kilograms, and it is at a height of 2.1 meters above the floor. What's its gravitational potential energy relative to the floor? Well, we have an equation for that. Gravitational potential energy, EG, equals m times g times h. The mass we're given is 3.8 kilograms. G, since we're on Earth, is 9.81 meters per second squared. The height relative to the ground is 2.1 meters, and we plug all that into the calculator. We'll get a number of 78.2838 on the calculator, but we look at the data. We have 2 sig digs for mass, 2 sig digs for height, so our final answer should have 2 sig digs. Our final answer should be 78 joules. Number 42. A 27 kilogram child sits atop a playground slide. So here's your playground slide. Here's this child. And the child is 2.8 meters above the ground. The child has a mass of 27 kilograms. So if we're looking for potential energy, we use the formula m times g times h. The child has a mass of 27 kilograms. We're on Earth, so gravitational acceleration is 9.81 meters per second squared. The height above the ground is 2.8 meters, so the potential energy relative to the ground is 741.636 joules. But we're concerned with significant digits for our final answer. 2 sig digs, 2 sig digs. Final answer should just use those 2 sig digs, the 7 and the 4. So we'll have to write that number using scientific notation. 7.4 times 10 to the power of 2 joules. 7.4 times 10 to the power of 2 joules for the final answer. Number 43. A roller coaster raises its passengers a vertical distance of 42.1 meters above the ground. So that's probably going to be our height. If the total mass of the roller coaster and passengers is 5.27 times 10 to the 3 kilograms, well, that's our mass. What's the gravitational potential energy of the roller coaster and passengers relative to the ground? And then how much work did the engine do on the roller coaster and passengers in carrying them to the top? So, first part, what is the gravitational potential energy? We know the equation for that. Let's plug in the numbers. Mass is 5.27 times 10 to the 3 kilograms. To be clear, that is a 5. G, since we're on Earth, is 9.81 meters per second squared. And the height we're talking about relative to the ground is 42.1 meters. Because the mass is so big, 5,000 or so kilograms, the amount of potential energy is going to be quite large. Multiplying all those numbers together gets us 215,1735.21, and that would be in joules. Now, what does our data tell us in terms of rounding? 3 significant digits for height, 1, 2, 3 significant digits for mass, so we should only have 1, 2, 3 significant digits in our final answer. So our final answer would be 2.15 times 10 to the power of something. 10 to the power of what? Well, we'll move this decimal over once, twice, 3, 4, 5, 6 times so that it can get behind the 2 there. So that is 2.15 times 10 to the power of 6 joules. The question also asks how much work did the engine on the roller coaster do to carry them to the top? Well, we know that work equals the change in energy of the object. Well, if the object gained 2.15 times 10 to the power of 6 joules of energy by going to the top, then that's how much work was done on the object itself. So the amount of work done is the same as the change in energy, 2.15 times 10 to the power of 6 joules. Okay. Number 44. How far would you have to lift a 1.2 kilogram book to give it 40 joules of gravitational potential energy? So here we have, or we'll start with our m times g times h formula. But don't just plug numbers in. What are we asked? We're asked, how far would we have to lift the book? So we're really asked, what is the height of the book? So we want to get h by itself. It's being multiplied by m times g. So the way you can get h by itself is, if you divide by m times g, m's cancel out and g's cancel out, you have h by itself. Just got to do that on both sides. And you'll see that you should end up with the equation h equals gravitational potential energy divided by mg. We plug in the numbers. 40.0 joules is our gravitational potential energy. The mass of the book is 1.2 kilograms. We are on the planet Earth, so 9.81 meters per second squared is the gravitational acceleration, or little g. When plugging this in your calculator, make sure to have 40 divided by the product of 1.2 times 9.81. So maybe this will be easier to see, but you want 1.2 times 9.81 on the bottom, and you want to put brackets around that if you're plugging it into the calculator. And doing so, you should end up with 3.39789, etc. joules. Now let's take a look at sig digs. 2 significant digits for the book, 2 significant digits for the mass, 3 significant digits for potential energy. You go with the least amount of significant digits, so we should just round to 2 sig digs, and our final answer should be 3.4. Sorry, that should not be joules. Height is in meters. So this is 3.4 meters should be our final answer. On to number 45. A chairlift did a certain amount of work on a skier to carry the skier on top of the mountain. How high is the top of the mountain relative to the base of the lift? Okay, here you have to think. Now, we did work on an object. The amount of work we do on an object is going to give that object energy, or the work done is going to transfer energy to the object. And the energy transferred is going to be gravitational potential energy, because we're lifting that object up. So this change in energy that the object has equals the gravitational potential energy, which equals, as you know, m times g times h. So if we did 5.60 times 10 to the 5 joules of work on the object, that equals how much gravitational potential energy that object has. Okay, now, what does the question want? How high is the top of the mountain? So now we know we have a gravitational potential energy amount, 5.6 times 10 to the 5. We know that equals m times g times h, and we know how to isolate for h. Divide both sides by m times g. So we know that h equals Eg divided by m times g. We have Eg is 5.6 times 10 to the 5 joules. M is the mass, which is 64 kilograms. We multiply that by gravitational acceleration on Earth, 9.81. We should round our answer to 1, 2, 3 or 1, 2, so 2 significant digits. So let's see what I end up to the correct number of significant digits. 8.9 times 10 to the 2 meters for my final answer. Number 46. How high would you have to throw a 0.3 kilogram baseball so that it would have 120 joules of gravitational potential energy at the highest point relative to the ground? Okay, so that's just Eg equals m times g times h, and we isolate for h, which you know how to do now. So you should be able to get to height equals Eg divided by m times g. Plugging in the numbers, we have 120 joules on top. Mass is 0.3 kilograms. We multiply that by g, which is on Earth, 9.81 meters per second squared. And we have here 40.77 meters. Let's look at our sig digs. 1, 2, 3 sig digs for mass. 1, 2, 3, 4 sig digs for energy. So we'll go for the 3 sig digs, the least amount of sig digs in our data. 1, 2, 3. Our final answer then should be 40.8 meters. Number 47 here. We did a certain amount of work on a box of books while carrying it a vertical distance of 3.3 meters up a flight of stairs. Essentially, we lifted up all these books 3.3 meters high. We know that since we did work on an object, that work is going to be transferred to the object and give the object energy. If the books are above a certain height, then we gave that object gravitational potential energy. So we know the formula for that is m times g times h. We want to figure out what was the mass of the books. So we isolate for m. How can we isolate for m? It's being multiplied by g times h. So we divide by g times h. The g's cancel, the h cancels, m is by itself. We have to do the same thing on both sides. And we'll end up with mass equals the gravitational potential energy divided by g times h. Plugging in values, 583 joules on top, divided by g of 9.81 on Earth, being multiplied by the height of 3.3 meters above the surface. And we'll get 18.00 kilograms, or 01 kilograms really. But we only want to round to 2 sig digs versus 3 sig digs. So to 2 significant digits, this is 18 kilograms. Final 2 questions. Let's look at 48. A child is swinging on a playground swing. She reaches a height of 2.8 meters above the ground. She has 604 joules of potential energy relative to the ground at that highest point. So what's her mass? Eg equals m times g times h. We want mass, so we divide both sides of the equation by g times h. And we'll end up with mass equals Eg divided by gh. Our potential energy is 604. G on Earth is 9.81. The height we're given is 2.8. Make sure to put that in brackets in your calculator. And if energy has 3 sig digs and height has 2 sig digs, we want to round our answer to just 2 sig digs. Our answer should be 22 kilograms. Last one here, 49. A boulder rests on a ledge 36 meters above a lake. At that point, it has 2.8 times 10 to the 5 joules of gravitational potential energy relative to the lake's surface. What's the mass of the boulder? Again, Eg equals m times g times h. You want to figure out what the mass is, so divide both sides by gh, and that gives you a formula for mass. Eg divided, let me write that more clearly, Eg divided by gh. Plugging in values, we were given 2.8 times 10 to the 5 joules. On the bottom, 9.81 times 36. I get 792.8 kilograms. However, 2 sig digs in our data mean we need 2 sig digs in the final answer. So our final answer should be 7.9 times 10 to the 2 kilograms. Let me write that more clearly. 7.9 times 10 to the 2 kilograms. Now, if you're having problems plugging in the numbers in your calculator to get the same number as me, first of all, remember to put brackets around the bottom line. But also on the top line, if you're dealing with scientific notation, on your calculator, best practice is not to write this. Don't write that number as 2.8 times 10 to the 5 that way. Use that E or EXP button in your calculator. So in your calculator, it should look something like this. 2.8 times 10 to the power of 5. So that's what that E means, times 10 to the power of. Right, so instead of writing that top line, write this bottom line. Your calculator will function more the way you like it if you're using that exponential function. All right, if you need any help on this, remember, tutorials are still on every Tuesday and Thursday at 1 p.m. It's always that same link. Thanks.